what is a acid? An acid is essentially, as you know, one which can give H plus and a conjugate base. For example, HCl can give H plus and its conjugate base Cl minus. Acetic acid CH3COOH can give acetate ion conjugate base and H plus. Now, the conjugate base always carries minus charge. Any charge, whether it is positive or negative, is a burden, a nuisance, a headache. Do you want to have a headache? Nobody wants to have a headache. So any factor that increases the burden makes the system unstable. Therefore, if there is any factor that minimizes the negative charge on the conjugate base, makes it a readily possible species that can be formed from acid. It means an acid can be better acid provided if its conjugate base is stabilized by any factor. Conjugate base is stabilized if somebody is going to minimize the negative charge on it. Therefore, all groups which have electron withdrawing inductive effect can make an acid better acid. Opposite is also to be considered. All factors which release the electrons, which increase the burden, more negative charge, make that very unstable. Therefore, all groups which have electron releasing inductive effect makes an acid less acidic. If you look at formic acid, HCOOH, it gives a formate ion. Now, if you look at acetic acid, now the acetic acid gives acetate ion and H plus. This acetate ion has an extra CH3, CH3COO minus, whereas formate ion is HCOO minus. Therefore, acetate ion, the CH3 group is destabilizing the negative ion. Hence, acetic acid is a weaker acid than formic acid. Agreed? If you compare formic acid and benzoic acid, now the formic acid is having HCOOH, HCOO minus is its conjugate base, whereas benzoic acid gives C6H5COO minus, benzoate ion and H plus. In benzoate ion, the phenyl group is electron withdrawing in nature. Any electron withdrawing group will minimize the negative charge on conjugate base, so it makes it more stable. It means benzoic acid is a better acid than formic acid. If you look at phenol, ethyl alcohol, after losing H plus, phenol gives phenoxide ion. Phenyl group is electron withdrawing, minimizes the negative charge on phenoxide ion. Therefore, phenol appears to be better acid than ethanol, because in ethanol, after giving H plus, ethoxide ion you get. The ethyl group is electron releasing. It increases the burden. Hence, ethoxide ion is very, very unstable. Very, very unstable means it won't form easily. It means ethyl alcohol is a poor acid. You got it? Now, if you are looking at base, a base is one which gains H plus to give its conjugate acid. Always conjugate acids have plus charge. So any factor that minimizes the plus charge makes it readily formable. It means a base will be a better base if it has an electron with electron releasing group, right? If you compare ammonia, ammonia gives ammonium ion, which carry NH4 plus charge. If you compare with methylamine, methylamine has CH3 NH3 plus. Now the positive charge on this methyl ammonium ion is minimized by inductive effect, plus a inductive effect of methyl. Therefore, methylamine is a better base. Now, if you look at dimethylamine, there are two methyl groups. So, dimethylamine appears to be still better base. However, there is another problem called steric hindrance. Therefore, we can't really extrapolate this idea beyond this limit. There are some variations. But as a fundamental rule, any electron releasing inductive effect can make a base better base. Any electron withdrawing inductive effect can make an acid better acid. Also, you see, a nucleophile is one which carry minus charge. In methyl chloride, the Cl, if you can separate as Cl minus, then I can call it as the nucleophile is being removed. When you remove the nucleophile, CH3Cl after removal of nucleophile gives CH3 plus. You got it? And if you really react CH3Cl with NaOH, and if you got CH3OH, Cl minus is replaced by OH minus. Hence, it is called nucleophilic substitution reactions. In a particular variety of nucleophilic substitution, first step is formation of CH3 plus or R plus or carbocation. Now, any substance that has plus I groups, which have a tendency to release electrons, will stabilize the carbocation. Therefore, that kind of reactions called nucleophilic substitution reactions are encouraged by plus I groups. It means if you have tertiary butyl chloride, where Cl is locked to a carbon which has 3 methyl groups, the tertiary butyl chloride can easily undergo SN1 reaction than secondary butyl chloride. Because in secondary butyl chloride, the carbon locked to Cl has only 2 alkyl groups. More alkyl groups, more electron releasing nature, more stability of carbocation. If you look at what is called as Grignard reagent or MgX, in Grignard reagent, there is Mg which is electron releasing in nature. Therefore, the carbon gets a minus charge. In Grignard reagent, the carbon always carry minus charge. The carbon which is locked to magnesium is existing as carbon ion in one way. Therefore, they are strongly basic, right? Now, very, very interesting point I want to mention is, if you take methyl chloride, CH3Cl, the carbon of methyl chloride carry plus charge. If you react methyl chloride with magnesium, you get methyl magnesium chloride. The magnesium is sitting between carbon and Cl. The moment the magnesium is sitting, now the carbon charge becomes minus. In methyl chloride, carbon is plus. In methyl magnesium chloride, carbon is minus. There is a 100% change in the nature of charge. This change in nature of charge has been caused by magnesium. Therefore, the magnesium which is changing the nature of charge is called Umpola. About the effect of all this plus I minus I effect on technical grounds. It can make certain acids stronger acids, certain bases strong bases. It can make certain acids weak acids, so on. The exact commercial questions in a table format we see. In all, I am going to present you with some 15 fundamental model questions. If you are through these 15 fundamental questions, you can kill any damn question related to inductive effect in any damn competitive exam. Try to follow that, and please observe it carefully and call me back if the clarity is lacking. Okay, with that note, I thank you very much.